So now, in this video we're going to look at my DIY project that I got going on now. So all it is, here is the two series. They're connected at the bottom. I'm not going to show that, but both of these battery packs have a bus bar like that, but then there's a bus bar across there, so that down here the two parallel sets of batteries are connected in series. So we're going to have about when they're fully charged, about 8.4 volts or so. And so I'm going to turn this on, and we can actually measure the voltage. So I have an XT60 connector there, like this one, but I just clipped the alligator clips on there from the bench power supply, because the bench power supply will limit current if we short circuit. The batteries will not limit current if we short circuit. So I have wires here. They're too small. They're 16 gauge, but they're big enough for what we're going to do. They recommend 12 gauge there. So in any case, I'm going to plug the batteries into the side here, and the batteries will power the unit if you don't have power there. So that drains the batteries though. So in any case, let's go to charger, because these batteries need to be charged. So I changed the setting. So these are lithium ion batteries, but cancel. But there we go. But they charge to the same voltage as LiPo, so we can go up to 4.2 or higher, and it only lets me go down to 4.15. But I'm going to do that. Leave a little safety room for the voltage. So in any case, you can also change the current. This can go up to 15 amps, and I'm going to keep it down to the 1 amp. Oh, I can go to I thought I could only go down to 1 amp, but I can go down to 0.5, even 0.1. That's really nice. There we go there. So that's the charge, and the discharge, same thing. So this is a small battery pack, of course, and they're not LiPo, they're lithium ion. They're not intended for as much current. Make sure you only deal with the current the batteries are set for. But they're when I charge them, I get about 2,000 milliamp hours out of them, and so it should be pretty safe, even with one battery, to charge at 1 amp, but I usually cut that in half to 0.5 amps. So since there's two in parallel for each of the two series sets, that means that each battery is going to get about half an amp. And I keep accidentally turning it a little bit. So it's asking if I want to charge to 8.3 volts. I will say okay. So right now we have 1 amp going in, 7.4 watts, and that's the voltage times the current, and we have the milliamp hours there. It is measuring those. So right now we are charging this battery pack. So let me mention this quickly. These are adapters here. I got these multi-wire ones to measure the individual voltages. The wires are already tinned, so I just lift up the flap there a little bit, put them in there, and then screwed it down. I don't have the 5.5 millimeter socket wrench, which I should have, so I've been screwing it down with the pliers, so there's all kinds of scratches and stuff. But in any case, we got first the negative one. That's the black one, so that's got to be at the end there. Next to it is white, so we're going from that part of the battery down, and we attached it there. So down there's a bus bar going across there to connect these two batteries together. And then we come over here, we got the yellow one, the third one, and that's how it is measuring the voltages. And then I have these XT60 adapters, and they're just bare. You put the wire up there and then solder them. There's like a little cup or something, and hopefully I'll get good at that. Can do a video. It's supposed to use 12 gauge. All I have is 16 gauge, 16 smaller, and so I'm using 16, but that's fine for the current we're using. We're only using 1 amp of current. That can probably handle about 5 amps or so. And so yeah, I just soldered them there. The plastic was a little too short, and so there's bare wire, so I wrapped it with electrical tape. But in any case, on the other end I have connectors that you can crimp, and so I did that to the bare wire on the other sides, and then they're like little forks, and just slide them in there and then screw down the nut. So in any case, right now we are charging. So right now, if we were done charging from the voltage we started at to the voltage we ended at, the battery would be a 43 milliamp hour battery. Of course, it's charging. It's going to be charging for a while. We got 3.79 volts on one battery, and then 3.76 on the other volts. And this should be indicating when one is balancing. And that's one of the things these wires do, is they help balance them, because the main wires, they're charging them while they're in series. So it's applying a current, negative to the negative, positive to the positive, and then the batteries are already connected there, so the current path, there's one current path through them, and the one with the least amount of capacity is going to build up a voltage faster. And a fan kicked in to help cool this, so you probably hear that. Hopefully it's not too annoying on the camera. Usually these buzzes are worse on camera than in person. But in any case, it's really charging through these two wires, and the batteries can become imbalanced. So these wires help make sure that they stay balanced, and I think they can provide about 400 milliamps of current or something to help keep the voltages more in line. So that's really about it. We'll come back to this later. Alright, so now it's been going for about 40 minutes, as you can see there, and we got the 703 milliamp hours. So remember that we started, I think it was about 3.75 volts or something, and now we've gone up to almost 95 volts to one battery, and number one seems to always be a little bit behind. I think it helped equalize a little bit there. But in any case, over the last 40 minutes, so we've been pumping in 1 amp of current for the most part to the batteries. It makes adjustments. You can see it drop down once in a while. And again, I'm new to this unit, and so I'm just going by what I'm looking at for the most part. So I'm testing out the first battery pack I built and the unit here. So in any case, once we get to an hour, this should be about 1000 milliamp hours, because we've been cranking about 1 amp of current. So you can see that dip down. Looks like it is trying to balance them right now. But in any case, this milliamp hours, these were mostly charged already when I started, and so it's going to be lower than if I completely discharged it. So I'll try to charge it when it's completely discharged in a future video, and to see what the actual capacitance of these are. So now we just passed the 1000 milliamp hour mark, and it's been about an hour, which makes sense because we've been feeding the battery pack about 1 amp of current, and so that got us 76% charge from where we started at. We started at a high voltage. They were more than half charged to begin with, and so to get to this point, it took 1 amp of current about 1 hour. So now both the bench power supply and the Hobbymate fans are off. It's the bench power supply one that's really loud. But in any case, I keep getting this F to pop up, and there's lower current. So I think that's because we're really close to our final voltage now. And I don't know what the F means. Alright, we got 1 amp of current now, but it's doing stuff. But for the most part, as far as I'm concerned, we're about fully charged. But in any case, that's where we stand. So we're going to try to charge each battery to 4.15 volts. Stay a little bit below the 4.2 volts, which we don't really need to worry about with this because it's monitoring them pretty well. But we will end up with, since they're in series, about 8.3 volts. So now, we're really close to the 2000 milliamp hours. When I charge these batteries with a charger independently, each one of them provides about 2000 milliamps of hour, even though of energy, stored energy, even though they say 3000 milliamp hours on them. And so putting them in series does not increase the milliamp hours, the amount of available current. It just increases the voltage. And they are in parallel though, so we expect twice as much milliamp hours. And they were already mostly charged, so we didn't charge them all the way from like 3 volts to 4.2 volts. We started, I think it was like 3.7 volts in that range to about 4.15 volts. So we only charged it, you know, less than halfway, and so we expect that to be less than half of 4000 milliamp hours, or less than half of 6000 milliamp hours if they actually perform as they say they will. Of course, there's going to be losses too. I think that adds up into the milliamp hours there. But in any case, looks like current slowing down, and that's to make sure you don't shoot the voltage of the battery higher than what you have it set. It just lowers the current, and normally it will say constant voltage, CV, where it just holds a voltage at, in this case, 4.15, and whatever current it needs to do that, it provides. Alright, so I just hit a timeout. Looks like it stops at 2 hours for whatever reason. So that's where we ended up then, and I don't know why it keeps flashing like that, but in any case, I'm going to end this video here. We should be charged. Let's try exit, and we tried to charge each one to 4.12. Let's exit again. Maybe it keeps flashing to catch your attention if you're wandering around or something, I don't know. But in any case, battery. And now it's looking at the voltages. So we got 4.07 on one battery and 4.05 volts on the other battery. So state of charge 87%. That's probably because it wants us to charge it to 4.2 volts. And so we're 87% from that. I'm guessing 0% is 2.5 volts per battery. That's my guess. And then of course it's probably looking at it, well, it is in series, so that 8.13 volts, not the individual batteries. But in any case, this is my first battery pack I put together. This is a new unit for me. I haven't charged battery packs of any lithium kind at all. And so hopefully I didn't make too many mistakes in this, and hopefully you still enjoyed it.